Okay, so for now we're gonna look into something interesting, and it is called Booleans. So we will continue here with Booleans. What do you understand about Booleans? Swift has a basic Boolean type called bool. Okay, that's one thing that we do know here. A type is called bool. It's a basic Boolean type. Boolean values are referred to as logical because they can only ever be true or false. Swift provides two Boolean constant values, true and false. Let oranges are orange is equal to true. Let turnips are delicious is equal to false. The types of oranges are orange and turnips are delicious have been inferred as bool from the fact that they were initialized with Boolean literal values, as with int and double above. You don't need to declare constants or variables as Booleans if you set them to true or false as soon as you declare them. The type inference helps make Swift code more concise and readable when it initializes constants or variables with other values whose type is already known. Okay. Boolean values are particularly useful when you work with conditional statements such as if statement. I think one of the things that I like here is how the if statement doesn't really this doesn't if statement. It doesn't even take uh, doesn't make use of brackets. That's one of the things that really surprised me when I was looking into this. Let me jump back here. Okay, cool. What example are we gonna make? What can we make an example of? Let var status. I'll just say true. So we can say if status. It's so confusing. It feels so foreign to do it this way because I don't know what next to do. Print. Okay, let's try to print status. I want to see what it stores inside. Okay, it printed true. So, well, I guess the interesting thing about this is that because we understand with C++, we use 1 and 0. That's pretty much how we use it. We use 1 and 0, but then here it uses true or false. It doesn't use 1 or 0. So that's true. So pretty much what is going to print here is going to print true. That's it. That's it with it. If turnips else print. Okay. Conditional statements such as the if statement are covered in more details in control flow. We'll get to that. Swift's type safety prevents non-Boolean values from being substituted for bool. Okay. The following example reports a compile time error. Okay, I think we get this because obviously if we declare something as a, for example, this is declared as a number, as a numeric value, and so therefore it's not a logical value. It cannot evaluate to true or not, to true or false. Therefore, it cannot work in an if statement. However, the alternative example below is valid. I is equal to 1. If I is 1, which yields to true, therefore that statement is correct. The result of I is equal to 1 comparison is of type bool, and so this second example passes the type check. Comparison like 1 is equal to 1, like I is equal to 1 are discussed in basic operators. As with other examples of type safety in Swift, this approach avoids accidental errors and ensures that the type intention of a particular section of code is always clear. Is this it? Yep, that's it. Okay. All right, cool. That's it with Booleans. Straightforward, I think. Straightforward. Very straightforward. Okay, thanks, guys. Cheers.